Hello everybody, welcome to the Math Hive, and today we're going to be looking at some of the hardest statistics problems to show up on the SAT. Now there are two main reasons as to why I'm doing this. Number one, statistics is one of those topics that most schools don't teach as well, and most students don't get to learn like a full-on statistics class until they've taken the SAT, until they reach 11th or 12th grade. And with the new digital SAT, obviously the math problems can get harder and harder. I remember the first digital SAT that came out, the math section spooked a lot of people, so we got to be prepared for these really hard type questions. That being said, let's move on to the first question, which I have shown up here. So this question is a study of cell phone use, and we have a table. One column is looking at texting behavior, and we have from light to medium to heavy. And then we have these two columns right here. I guess I should call these rows. And we have these two columns right here, which is talking on cell phone daily and does not talk on cell phone daily. So let's read this question. In a study of cell phone use, 799 randomly selected U.S. teens were asked how often they talk on a cell phone and about their texting behavior. The data is in the table above. Based on the data from the study, an estimate of the percent of U.S. teens who are heavy texters, so that'd be this box right here, is 30%, and the associated margin of error is 3%. Which of the following is a correct statement based on the given margin of error? So this is this fundamental concept of statistics, where when we conduct a study, right? We conduct a study on U.S. teens. Why did we only pick 799? It's because obviously we can't ask every U.S. teen. The whole point of studies like these in the real world and in these problems is to predict what the whole population's behavior. We look at a couple random teens to figure out what all the teens are doing. So this study is saying, based on what we found in this data here, we can predict that the percentage of teens who are heavy texters is somewhere around 30%. It's not going to be exactly 30%, but it's going to be pretty close. And they said the margin of error is 3%. So what they're saying is we estimated 30%, but we could be 3% wrong. It could be as low as 27%, which is 3% below 30%, and it could be as high as 33%, 3% above 30%. So this is what we're predicting, but it could be anywhere between 27% and 33%. That being said, we can go through each of these options. So A says approximately 3% of teens who are in the study who are classified as heavy texters are not really heavy texters. That's not what that's saying. That means you assume 3% of them incorrectly. That's not what we're talking about here. We're saying our prediction for the population could be 3% wrong in either direction. It is not possible that the percent of all U.S. teens who are heavy texters is less than 27%. Well, it technically is possible. Again, this study is to help us predict. What our margin of error is saying is that it is likely to be anywhere between these two numbers, but there is a chance, a small chance, that we could have something like 26%, or that we could have something like 34%. And that's what they're trying to trick you here with. They want you to think that based on the margin of error, this is where it has to be. We could have just picked like a higher group just by chance. We could have picked a higher group when it actually is the average is 26%. So no, it is possible, but it's a low chance. The percent of all U.S. teens who are heavy texters is 33%. These kind of questions you can eliminate right away because they are making a statement. The percent of all U.S. teens is 33%. We have no idea what the percent of all U.S. teens is. That's the whole point of the study. We're trying to predict it. But a person might look at the end of their interval here and see 33%, and they'll go, wait, okay, yeah, then it could be C. But that's not the case. It could be anywhere between 27 to 33%. That's what's likely. It is doubtful, keyword doubtful, that the percent of all US teens who are heavy texters is 35%. So like I said before, the margin of error, this interval right here, is where it's likely to be. But I said before, there is a chance that it could be outside this interval. So it could be as high as 35%. There is a chance, but if you recall, I said there was a low chance, which is why we'd be doubtful of it. So now we have found that our answer is D. If you want to look more into these concepts, I suggest you look into confidence intervals, because that's actually what we did here, and margin of error. Alright, so we have another question here, looking at a table of contestants by score and day. We have our days along the rows here, and the scores along the top here, and then our totals on the side. So let's read this question. The same 20 contestants on each of 3 days answered 5 questions in order to win a prize. Each contestant received 1 point for each correct answer. The number of contestants receiving a given score on each day is shown in the table above. No contestant received the same score on 2 different days. If a contestant is selected at random, what is the probability that the selected contestant received a score of 5 on day 2 or 3, given that the contestant received a score of 5 on one of the 3 days? So there's 3 key pieces of information here. Number 1 is that we can't have duplicate contestants, in a sense that if a contestant scored a 5 on day 1, they could not have scored a 5 on day 2 or 3. If they scored a 3 on day 2, they could not have scored a 3 on day 1 or day 3. The second piece of information is that they want to know the probability of selecting a contestant that received a score of 5 on day 2 or 3. And the third piece of information is that we're given that the contestant received a score of 5 on one of the 3 days. So what we need to do is figure out our total group that we're looking at. If we were just picking randomly from all of these contestants, we would be looking at all 60 cases. If we were looking at a single day, we would be looking at all 20 contestants for that day. However, what we do know is that we're given that the contestant received a score of 5 on one of the 3 days. What that means is that they're saying, what is the probability that we pick one from day 2 or 3 of the group of people that received a 5 on one of these 3 days? So the question is, how many people received a 5 on one of these 3 days? Well, it's this total right here, right below this 5 column. This total added up all these 3 days for the 5 out of 5. That means 7 people, 7 distinct people, because no one can repeat their score, got a 5 out of 5 on these 3 days. There's a total of 7 people to pick from. And now they're asking us, what's the probability that we pick a person from day 2 or 3? Well, how many people are from day 2 or day 3? Well, there's 2 people on day 2, and there's 3 people on day 3. So that means we could possibly pick 5 people, right? 2 plus 3 is 5. We could possibly pick from these 5 people out of the total, which is 7. So our probability of picking 5 out of 7 people is 5/7. If you want to look more into topics like these, you would be looking at conditional probability and using our and/or probability equations. So this is the last question I want to go over, and in this question we're using these things called box plots, or you've heard of them called as box and whisker plots. We have 2 of them right here, and let's go ahead and read this question. The box plots summarize the masses in kilograms, so our units, of 2 groups of gazelles. Based on the box plots, which of the following statements must be true? So you guys have probably seen this in your other classes, and maybe you remember it, maybe you haven't, but I'm going to quickly go over what our box plot is. So a box plot is just a way to describe some data. I've drawn a box plot over here, and we're going to make this match some data that we got from a set. So this is data right here, and we got it from 5 middle school students, and we asked them how many hours of TV do you watch a day. One student said 0, one student said 2, 4, 5, and 6. And we decided to display that data. We could have displayed it in any way we liked, but we decided to display that data in a box plot. So our box plot shows us 5 different things. It shows our minimum value, it shows our maximum value, shows our median, which is our middle value, our first quartile, and our third quartile. So our minimum and our maximum are self-explanatory. There are lowest and highest values. Our median, the middle, is also pretty explanatory. When you arrange in order, it's just the middle value. Our first quartile is the middle of the minimum in the middle. So it'd be the middle between 0 and 4, which is 2. And our third quartile, if you can guess, is the middle between the median and the maximum. That'd be 5. So if we go up to our actual question over here, we can start identifying this is the minimum, this is quarter 1, this is the median, quarter 3, and this is our max. And same thing down here. This is our max, quarter 3, our median, quarter 1, and our minimum. So now that we've identified all these things, we can attempt this question. So it's asking which of the following statements must be true. So the first question is asking about the mean mass of group 1 and the mean mass of group 2. If you don't know what the mean is, it's when you take the average of all the values, which you do by adding them all up and then dividing it by the number of values you've had. And I'll tell you this right now. If you have a question regarding a box and whisker plot and they ask about the mean, it is almost always wrong, because our box and whisker plot does not tell us anything about the mean. It tells us something about the median, but it does not tell us anything about the mean. We have no idea where our mean could be, because there could be tons of values in this area, tons of values in this area. We have no idea. It only tells us about our median, which automatically eliminates the questions A and B. Right, answer options A and B, because both these are trying to compare the mean, which we don't know. Options C and D are comparing the median, which we do know, and now we can figure out which one this is. The median mass of group 1 is greater than the median mass of group 2. So if we look at the median of group 1, which is right here, and we go all the way down, this median is at 25. And if we go to the median of group 2, so group 2's median is 24. And so now we can compare these, 25 and 24. Group 1's median is greater than the median of group 2. So that means C is our answer. I hope you guys enjoyed this video. If you would like to see more statistics content, or where I actually go into explaining these concepts rather than going straight into the questions, please do let me know. And if you have any other questions, video ideas, or feedback, let me know in the comments. Thank you for watching.